Forrest Breyfogle here. In this session, I'm going to be describing how to report non-conformance rate metrics so the right behavior occurs. The data set that I will be using for this illustration is taken from the book Management 2.0. The figure that I'll be recreating is figure 9.9. The book references an app for creating these particular types of charts, which I call 30,000 foot level reports. The link that is provided in the book is also provided on this slide. So if we were to examine the particular chart that we want to create, this is what it would look like in the book. I've also highlighted in yellow additional information about this particular chart that we want to recreate. By clicking on the link that was provided earlier, one would gain access to this EPRS metric tool app, where EPRS stands for Enterprise Performance Reporting System. If we click on the tab that says View Example Datasets, what we will see is all the datasets that are included in this book. The one that we're interested in for this illustration is figure 9.9. By clicking on that particular entry, we will download the data set to our computer. This is what that particular data set looks like. Let's now return back to the home page for this EPRS metric tool app. The first thing that we want to do is find the file that we want to analyze. And as I noted, it was downloaded to our computer. So I'm opening up that data set that I just showed you previously. We could notice that the upper left corner of that spreadsheet now appears as a snippet in the right side of this entry. For our particular set of data, we would select Attribute. The column that we want to analyze is non-conformance rate. So I'm doing a Control-C and Control-V. What appears now is a chart that's up in the upper right-hand corner. What we notice is that it's a time series chart, and upper control limit and lower control limit values are calculated statistically. It's not a P chart. A P chart is often used for this type of data when controlling processes. But for this high-level view of an output of a metric, that particular type of chart has issues as described in the book that I referenced earlier. Now we notice also that if we have a stable process that is no values beyond the upper and lower control limit boundaries, then we can say our process is predictable. The estimated performance for this particular process is 0.045. Some months are going to be higher and some months are going to be lower, but that's basically the capability of our process. The important point here is we don't react to all the ups and downs. If the value of 0.045 is unsatisfactory, then we need to change our process. Proof of the pudding that our change was beneficial to the metric is this particular metric would be staged to enhance level of performance. Now, to clean up this chart, we need to do some things. We can change the x-axis to months. We also, instead of percentage, we have a rate value. Change that to rate. We can add a chart title, which may be non-conformance rate. We can add a y-axis value, which would probably be rate. An x-axis value might be month. So if we were to scroll back up to our chart, we would notice now that all our entries that we made have been included. So in summary, I described a methodology to use an app so that you can create 30,000 foot level charts. So if you have any questions about the recreation of this chart, or you may have a particular set of data that you would like to create a 30,000 foot level chart of, please contact me at info@smartersolutions.com or 512-918-0280.